Hello, I'm Fred Devrière, Marketing Manager for Assembly Services at Teledyne e2v. Here at Teledyne e2v, we have a long heritage of supplying the space industry with various types of components, especially our data converters, who are at the heart of many missions around the world. In this video, we will discuss why we recently switched to organic packages for our components, what are the implications, and how we work to keep the reliability at its maximum. Space missions are traditionally designed for durations from 7 to 15 years. This implies a very high reliability for all components, as it is not possible to replace a defecting part in orbit. So traditionally, to assemble electronic components for space, all the industry has been using ceramic packages. This is because the CTE, the coefficient of linear thermal expansion, is very close between the silicon die and the ceramic. The stress at the interface between the die and the package is then minimum during the thermal cycle that the component has to withstand in orbit. And minimal stress means maximal reliability. But this last decade, the bulk of the market for packages, driven by consumer or automotive, for example, has really moved to organic packages. So they have benefited from huge technical advances, while the technology for ceramic packages has hardly evolved. When designing our latest analog-to-digital converter, which comprises a track and hold and two ADC dies, we had to switch to organic packages. This is because the ceramic will not allow us to have dielectric layers thin enough to support the very high frequencies of our device. So the question is, how did we manage to have the required level of quality? Actually, our approach was based on three pillars. First, we had to be very careful in the selection of the different materials making the assembly. We choose them so that they create the minimum stress possible around the silicon die. And another criteria was the low outgassing, which is a strict parameter for space use. The choice of material was for the organic substrate, the underfill, the TIM, the thermal interface material, and the lead attached glue. Secondly, we use very conservative design rules for the package routing in regard of the main defect contenders. And thirdly, we made extensive simulations both to tune the design with our strict design rules and to evaluate the reliability of the ball attach from the die to the substrate. We also made a first proof of concept design, which has permitted us to make some trials on a real device. So, as a conclusion, Teledyne e2v has now a complete process for space-grade assembly. And the very good thing is this process is now qualified. We are now working towards integration of heterogeneous technologies on an organic substrate, and I'll soon be happy to post another video on that topic. Meanwhile, I encourage you to go on our website to learn more about our outstanding space product. Thank you for watching, and if you have any questions, don't hesitate to contact me. See you next time.